So, we hear healthy soils. We call it just soils management. What is a healthy soil? It's a little hard for most people to get their head wrapped around. But to kind of ground us all on all the different components of a soil and how management practices that we'll talk about today impact that, we're happy to have a partnership with the Western Regional Certified Crop Advisors. And so Erin Wingate will start us off with kind of a Soils 101. Thank you.
All right. Hi, everybody. Thank you so much for being here today. My name is Erin Wingate, and I'm the lead agronomist at TriTech Ag Products in Ventura County. And like Josette said, I'm here today representing the Western Region Certified Crop Advisors, and I'm on the board for that organization. And we do a lot of work trying to get educational content out and get people to become certified crop advisors, so that when you're on the farm and maybe you're a PCA already and you're doing all of the pest control, you're walking it every day, maybe you're a grower and who knows the farm better than you, right? Nobody. But with the CCA, you can understand the soil science, nutrient management, water quality, water chemistry, and all of that to a higher level. And with that broader understanding, we can do more to protect our soils and make sure that they can continue sustaining our food supply for the long term. So since today is the Soil Summit, we thought we would start things off by giving you a Soils 101 talk. All right, so we're going to start off by talking about just what is soil. We need to have a working definition for it. And then we're going to go through different ways we can measure and quantify soil health. It's more than a buzzword. There are a lot of measurements we can take to see how the different soil qualities are being affected by management and track progress as we implement changes. And so we'll go through the physical, chemical, and biological measures. Some of them you'll be familiar with, maybe some of them you're not. And then I want to talk about some of the beneficial soil services when you have a higher degree of soil quality and what we can expect and why we would implement these sorts of management changes. And that about wraps it up. So here's our working definition of soil. Soil is the unconsolidated mineral or organic material on the immediate surface of the earth that serves as a natural medium for the growth of land plants. So soil is really what makes life on earth, on the land, possible. It sets the foundation for all of the other organisms. Soil is vertically differentiated. It's formed out of rock and broken down through different weathering processes, physical processes, biological and chemical, that transform raw rock into what we know as soil. And there are many, many different types of soils all around the world. California has a very diverse range of soils, and understanding what's on any given field can help inform the way you manage it. So the soil composition, this is an important piece. It's not just one solid mass. It has a mineral phase, it's got liquid, and it's got gas. So we think of soil in these proportions. In an ideal setting, you would want to see about 5% organic matter. And here in our arid environment, that's usually not possible. We see lower organic matter percentages here because of the amount of rainfall that we get and the amount of tillage that we do. There's complicated answers to that. But we do want to see this proportion, about 45% mineral material, and the rest should be pore space. And in that pore space, maybe 25% soil solution or water, 25% soil atmosphere, this is the gas. And that's very important to maintain the health of the crop's roots, because we need to provide enough oxygen to get to those roots and support their healthy growth. The pore space also allows the roots to grow without any difficulty getting through a compacted soil. So that brings us to our first physical measurements. Most of these you can do in the field yourself. And if you go and search online, there are lots of soil evaluation PDFs that you can download that can explain how to do some of these tests. So the first one up that's important to think about is aggregate stability. Soil aggregates are particles held together tightly via root exudates and microbes, and they are very sensitive to field management decisions. So the soil microbiome is this living mass of many, many types of organisms, and their populations are constantly turning over. They're growing, they're dying, and microorganisms, I like to think of them as having their stomachs outside of their bodies. They send out enzymes, organic acids, and this organic liquid goop. And all of that stuff serves to coat the mineral particles of the soil and help it clump together into stable aggregates. And when the soil clumps together in that way, it forms pore space. And that pore space is what allows the free infiltration of water and air. And so if you look online, there are different tests that you can do to measure the stability of your soil aggregates. And that gives you an indicator of how well your soil structure is doing. And so then on the opposite end of the spectrum, the soil compaction happens when that soil structure begins to break down. And a compacted soil has smaller pores, fewer pores, and it's not allowing water and air to move freely throughout the profile. So in a few other physical measurements are available water capacity. You're all probably more familiar with this one. Water holding capacity changes depending on how much clay you have. A sandy soil will have a lower water holding capacity than a soil that's high in clay. But also organic matter contributes a whole lot to water holding capacity. So as you start to build more organic matter in the upper layer of the soil, you can expect to hold more water. And then water infiltration rate, that's tied to the compaction piece. It's also tied to salinity. And so you can measure in the field how long it takes for a given amount of water to filter down into the soil profile. And that can help you determine if you're likely to have runoff during a big storm, or maybe it can help you figure out what you want your irrigation injection rate to be. So now we're going to move on to the chemical measurements. You guys are probably a lot more familiar with this. This is the basic soil suitability analysis that you send to the lab. You take samples maybe every year, once maybe every 5 years, and they give you this report back. And so when I get one of these reports, I immediately look at the soil pH and the soil salinity. And it depends on the lab you're working with. On this report, salinity is given in a percentage. On other reports, you'll see it in other units. So just become familiar with your lab's reporting and understand what those different units of measure mean. But you want to look for a salinity level that your crop can tolerate. Different crops are more or less sensitive. And then soil pH, same thing. Different crops have different sensitivities to pH, but more importantly, pH has a big impact on nutrient availability. And so if you have a very high pH, you can predict things like low zinc and phosphorus availability. And if that's the case, then you might need to adjust your fertilizer program to compensate. So I look at those two first, and then I look at what is the soil's cation exchange capacity. And that's a measure of the soil's nutrient bank account. The cations, calcium, magnesium, potassium, they have a positive charge, and the soil has a negative charge. So these positively charged nutrients will stick onto the clay surfaces, and that gives you a bank of nutrients that will then buffer into solution as the plants take them up via the roots. So this soil has a CEC of about 20, and that's considered pretty high. So that's reassuring to me because I know that the soil will be able to hold any nutrients that I deliver via the fertigation and make them available to the plant throughout the season. But then looking at the soil report, I can see that phosphorus is very low, but potassium is very high. So those are things that I want to address in the fertilizer program. Cut back on my potassium, maybe increase calcium, and definitely apply phosphorus. So this is where it gets a little bit fun and the new frontier. Soil biology is incredibly important, but we've just really been beginning to understand it and find ways to measure it. And these soil microbes have evolved with plants. There are not plants without microbes in the soil, and they have very specific relationships with each other. They have a back and forth where the plant exudes photosynthate or sugars through the roots that feeds the microbes, and then the microbes make nutrients more available to the plant. Microbes also send signals to the plant to tell it when to grow or when to defend itself against pest or disease or even weather events like drought or severe cold. And so we want to take advantage of these relationships as much as possible. And we also want to increase microbial activity so that we can build the organic matter that is important for the soil structure and water holding capacity and pH buffering, and so much more. But how do we measure that? And how do we know which management changes are making the biggest difference and what's going to pay off financially? So I'm going to talk about a few of these metrics, but the jury's still out. People are still debating which tests are worth taking. So the first is active carbon. And so soil organic matter is carbon-based. We're all living creatures made of carbon. But this form, this active form, this is the food source that's available to the microbes right now. It's the most available. Other forms of soil carbon, like humic acids, are less available. They've been stabilized and maybe have formed colloids with mineral structures, and they are important more for the soil's aggregate stability and the structure itself, whereas the active carbon fraction, that's important for feeding the living microbial communities. So you can contact various labs to see who does this or contact your CCA. And then the next is soil protein. And that gives an indication of the nitrogen that is held in the microbiome. It can help indicate how much nitrogen may release. And it is a way of judging how active and healthy the soil microbiome is. And then the next one, maybe some of you guys have heard of it. This is soil respiration. And it's a way to measure how much carbon dioxide is being released from the soil. Most soil organisms are aerobic like us, meaning they breathe in oxygen and they exhale carbon dioxide. And so the amount of carbon dioxide being released by the soil in a given amount of time indicates how active the microbiome is. And so we want it to be in a certain range to let us know that we've got a healthy living community. And you may have heard of the Solvita tests, which are available to order from a lab, and you can do that test yourself, and it's pretty fun. And then there's direct microbial counts. So you can all think of scientists in the lab with those little agar plates, and they're growing microbes on there, and then they put it under a microscope and they can say, oh, look, I've got Bacillus subtilis. And so that's one way to try to identify and estimate the number of different organisms in the soil. But it's got limitations because not all soil organisms can grow on those plates in the first place. So now some labs are starting to offer total genome sequencing. So they can take a soil sample and sequence all the DNA in that sample. And then they run that DNA data through a database of known soil organisms to let you know who is there and sometimes give an estimation of how many. But that one too, that is in its infancy. So it's hard to interpret what the data means all the time. Just because the DNA is there doesn't mean that it's active. And so if you want to go down that route, I would suggest reading up about it more, contacting the labs that do it and talking with the professionals or contact a CCA. So now that we've got ideas of how to measure the physical, chemical, and biological components of soil, we want to put all of that together. We can't manage just one aspect in a vacuum. So why would we try to holistically manage and care about the microbiome and care about how the water quality affects the soil chemistry and all of that? Healthy soils, they store water, they sequester carbon, they resist erosion, which is very important now. We've had some record storms and we expect that severe weather events will continue. And we don't want to lose our topsoil to erosion. And we don't want to pollute the natural water bodies with all of the fertilizer and chemical and nutrients that are in the soil. And we want to optimize land use, meaning we want to get the highest yield and be the most efficient with water and resources on every acre. So that goes along with improving the nutrient use. And also, of course, we want to be profitable. So we want to measure it and manage it. So these are just some tips to set up your sampling protocol. You want to be consistent with the location that you set. Because if you're going to implement management changes, you want to make sure that the measurements you take from year to year are really comparable to each other. And you can even use GPS to pinpoint exactly where samples were taken. And then you can store all that information in your own Excel spreadsheet or database or use software. And there's a lot of different software options on the market to do that. And then you want to make sure you sample before and after you make any of your major management changes. And then, of course, I'd say seek the technical support. You want to make sure that you are using the same lab consistently. Different labs have different methods. Talk to the people at that lab, understand the tests that they're taking and their quality control, understand how to interpret their report. And so there are so many people out there that would love to talk about this with you, and that's the lab people, NRCS, Certified Crop Advisors. It goes on and on, UC Extension. And then remember that the field conditions impact your test results. So you want to make sure to pull your soil samples when the soil is moist but not overly saturated. And you want to wait a few days, maybe even a couple of weeks, depending on how much fertilizer you applied. You don't want to take your sample right after fertilizing. And then you want to take notes on the conditions in the field. So what was the temperature, moisture level? What's the ambient air temperature? How deep was the sample that you took? And how deep was it last year? You want to make sure that, again, you're comparing measurements that make sense to compare. You don't want to take a sample one year 12 inches deep and then the next year 6. And then microbial analysis Those samples are pretty sensitive, so you want to wait 2 weeks after chemigation, and also make sure you contact the lab to know whether or not the sample needs to be sent on ice to keep it cold and prevent those microbes from dying on the way. So we got a couple of charts here. This is just showing how microbial activity changes with the depth of the soil and with temperature. So microorganisms are more active in warm soils, so you want to sample during the summer, and they are most active at the surface, and then they're fewer and fewer as you go down to lower depths. So we got this holistic management goal. We want to look at the soil's chemical analysis and do things that will help adjust the pH and make up for nutrient imbalances or deficiencies in the soil. We want to try our best to take care of the microbiome. And later on today, we're going to hear more about ways you can do that with mulching, cover cropping, and so on. And then if you've got issues in the field, of course, you can't always attribute it to soil quality. That's why we've got PCAs and look at our irrigation quality and all of that. So we want to contextualize the results. The lab report is only part of the story. So take good notes and try to look at everything and be a detective in the field. And so that's it. Again, my name is Erin Wingate. If you have any questions for me now, I'll take them, and if not, you can email me. All right, thank you.
Thanks, Erin. I think it's really helpful to kind of get that broad overview to help you think about all the different components and, as you say, trying to manage holistically to optimize and reduce the trade-offs. So for another view on kind of what soils mean in an almond orchard, we're going to hear from Bill Brush, an important consultant in our industry, and we'll cue up the video.
Hi, I'm Bill Brush from Modesto, California. We're a longtime family farmer in this area since the 1854 to be exact, and I still farm some of those same lands down in and around the San Joaquin River. Right now we farm almonds, walnuts, and a little bit of pecans. And basically I've been farming essentially all my life. From my dad was a farmer, my grandfather, all the way down, so it's been in me. Attended school at UC Davis, graduated in 1973, and my experience also includes time on the almond board, where I spent somewhere 13 to 14 years, both on committees, the PR and Advertising Committee, the Finance Committee, and also as an alternate to the board and also as a board member. And that was a great experience to get some of the information that I've learned over the years out. And I said before that, I also had time spent at an ag retailer, Stanislaus Farm Supply, for over 20 years. And then, which is most pertinent to this conference, and about 20 years ago, I started an ag consulting business. And that ag consulting business is focused on soils and soil health, and also water and water quality. So that's what I came here to speak about today. The soil is the growing medium for your crops. It's what sustains life for your crop. It's what sustains life for humans. It is the most important thing that we do. And even though we've had soil since time began, is so little known directly to the farmer as a lot of times as to what he needs, which is what I saw a point that farmers need to know more, and they need to know more of how things work, what the biological system is of this, and how it can best sustain you, not only as a grower, but as a grower that can be happy with the quality and quantity that you grow, and not just in any one year, but for the long term, creating healthier plants through healthier soils. Well, the first thing that I always I'm surprised about when I come to something like this is that they say, well, we're going to have a soil conference about healthy soils. So what do you want to say? I don't want a healthy soil? It's kind of ridiculous. Of course, we want clean air, we want clean water, and we want healthy soils. You wouldn't want unhealthy soils. So it comes down, what's that definition? And I kind of have one here that I like. And soil health is defined as the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. This definition speaks to the importance of managing soils so they are sustainable for our future generations, okay? The problem is it's the devil's in the details, isn't it? It always is. So I always tell people, if anybody comes and tells you with a solution and says, this is the only thing you need to do, run and run fast. Because it's always multiple things. So I'm going to tell you that key to soil health is not just one thing. But I will tell you, it is just one thing. And that one thing is the biology with which we have in the soil. The soil, a pinch of soil, if you go home, look at your soil, your garden, even your yard at home, and take a pinch of soil between your fingers like that. There's approximately at least 7 billion organisms in that pinch. In other words, you're holding the number of people that inhabit the planet just within your fingertips. And that's what you get out of that soil. The average soil, the crux and what really makes things grow is that top 6 to 7 inches, which we call the aerobic zone, which is the depth that air can get down through that soil. Because this microbiology needs 2 things to live, air and water. So if it can't get air, it's not going to survive. It's going to sit there in a spore form or in some form that will come back to life when it gets the proper amount of air and water. If it has not enough water, it does the same thing. So the key to growing anything is keeping the microbiology as happy and as robust as we can get it. So when I say it is the microbiology, but if you don't have your soil balanced, where you can get air down into that soil and get water to move through that soil profile, you're not ever going to be really successful at growing the top yields and sustaining your soil for the long haul. One of the things I hear all the time from, and everybody likes to put labels on things. The new buzzword now is either sustainable or it's regenerative. Well, the one thing that's good about sustainable, makes sense that we need to keep these growing and growing a long periods of time, on and on and on for generations. Because it is what sustains the human population. Without the soil, we would be gone in just a very short period of time. We have, if people stop farming today, we have less than 30 days of a lot of the things that we eat and consume every day. Think about that. 1 month, we'd be out of food. So the constant turnover of the soil and cropping and understanding of replenishing what we're removing and going back and regenerating those things that we're removing. The one thing that I've seen that I disagree a lot of times with certain people or certain focuses, when you look at regenerative ag, the one thing soil microbes, those mold, yeast, fungi, bacteria, all of those combined, the one thing they can't do is they're not manufacturers. So if I have an orchard here that is short of zinc, it can't make zinc out of anything. The only thing it can do is mineralize the available zinc and feed it to the crop you're trying to grow. But if you need higher zinc levels, or if you need higher calcium or magnesium or any of those levels, you need to add those to the soil. Now you can add those in some of the things you're doing, like you can do some composting, great things to do, particularly if you've got light sandy soils with limited ability to hold and store nutrients, because that function is held on the clay particles. And the definition of sand is essentially the lack of those clay particles. And so you need to know what I have here to start with, which is the first criteria that I tell all the growers that I work with. You can't fix what you can't measure. So we have to measure what's in the soil, and we have to put those nutrients that we're short of, or to balance out those major cations of calcium, magnesium, potassium, and sodium, and get them in the right balance, so that now that soil is able to receive water properly. It flocculates properly by the calcium molecules, basically pulling together, creating air spaces for those microbes to thrive in. So because of this particular situation, I have frequently taken growers to the orchard. We learn a lot by seeing what's happening in the orchard. And the first thing that we'll see when we get growers to the orchard is they look up. And they look up because that's where the crop is. Even when they're looking at field crops that may be waist high, they're looking at the grain, or they're looking at the money maker of there. And it's understandable that they want to know what crop it is. But I always say, take that vision and look down. Because down is where all this crop is made from. The nutrients are down in the soil. And we can add things to leaves, foliars, we can do a lot of things, but essentially the pounds, the meat, most of the volume has to come from the soil. So if we don't have it properly balanced, what happens next is we don't have the proper environments for the microbes. I've studied a lot from a professor. He's long since passed away, by the name of Dr. William Albrecht from the University of Missouri. And he taught a lot of soil science over the years. And what he said is, feed the soil and the soil will feed the plant. But what I like to add, and then the plants will feed the humans, or feed the livestock, or feed whatever that crop is intended for. And it's without that understanding that soil is where it comes from, that's where everything begins. The other thing that people don't understand, Dr. Albrecht also said one thing that I use frequently and tell people. He said, the microbes eat at the first table is exactly how he phrased it. Meaning, you ever go to a wedding and you got a buffet, who eats? The first table. Okay, and they get first chance at everything we put on the soil. And so they're going to take it and mineralize it. It's also known that anything that's went through a plant or an organism becomes more biologically available to the next generation, which is these trees that we're looking at. So they are important that we're thriving, being able to mineralize, because we make it easier for our crop to pick up those nutrients. We also look at, I know that everybody looks at what we apply because it costs money. So we keep real clear focus of what we're applying to the soil. How many pounds, how many units, not too much, just enough. Make sure we have enough to feed that crop. But nobody looks at it in terms of the nutrients that we apply. And the biggest ones we apply are the ones that we don't care much about, or we don't put a lot of consideration to, which is carbon, oxygen, and hydrogen. Those are what the plant cannot do without. Carbon dioxide to run photosynthesis, H2O, water, because it has to have water to live. So that is where it is. And if we can get our carbon areas built up in the soil, it's another form for those microbes, because they are carbon-eating machines. Remember, the soil has to do two things. It has to take air and it has to take water, both of them in. And a perfect soil, which Dr. Albrecht said, I like to say it's not necessarily the perfect soil, but it is the perfect condition for microbes and plants to take up. And that's about 50%, or 45% to be exact, of mineral, okay? And that's things you can't change, the clay, the silica, the sand particles, everything that you have here. 45% of your soil is that. If you're lucky, 5% is organic matter, or soil humus, true soil humus, which is a stabilized form of organic matter. 25% air, and 25% water. Well, what can change? The mineral can, and the organic matter doesn't change very much. So what changes all the time is water and air. Basically, we're putting on water, and we're taking out air. The air moves back in, and we're taking out water, and they're moving back. And the closer we can keep them to that 25%, equal amounts of air and water, or where microbes, the microbial population thrives, and the plants thrive. I've just given you a thumbnail sketch of what's really important about ag and farming, and how you make your soils healthier and getting them back to where we really want them to be. But what I really want you to know is these conferences are important because they highlight something that I think's been overlooked time and time again, in that we're worried about production, looking up instead of looking down. I want to get a generation of people that are looking down first, seeing what the soil tilth, the soil health, and how my soil is working, and then we'll see how well it's doing in the field. So if we can get that conversation started, I've done my job. I appreciate your time. Have a great conference, and I'll hopefully see people soon.